In the winter of 1883, fire brigades in Poughkeepsie, New York, were dispatched in the middle of the night. Citizens flooded the streets in their night clothes, certain the horizon was on fire. The sky burned orange and deep crimson. No building was burning, no forest was in flames. The firefighters confirmed it. Yet the sky continued to glow, and nobody could say why. Poughkeepsie was not alone. The same scene played out in New Haven, in Boston, in London, in Paris. Across the United States, Britain, and continental Europe, people stood in the streets and watched the heavens turn colors that no one had ever seen before. Shades of green so pale they seemed translucent, reds so deep they looked like old blood, blues that appeared near twilight and faded like a bruise across the horizon. Letters poured into newspaper offices. Some quoted scripture. Some demanded explanations from their governments. Some simply wrote that they were terrified and wanted to know when it would stop. The answer, had anyone managed to piece it together at the time, would have been stranger and more disturbing than most were prepared to accept. Those skies were not burning. They were glowing. And the reason was that roughly 7 months earlier, on the other side of the planet, something had detonated with a force so catastrophic that it had scattered a fine, invisible veil of volcanic glass and sulfur compounds all the way to the stratosphere. That veil was now catching the light of the sun and bending it into colors that the human eye had never learned to interpret. The loudest explosion in recorded human history had already taken place, and most of the world only realized something had gone terribly wrong when their own skies caught fire. Welcome to Epoch Reset. I am Elliot Carter, and today we are going deep into one of the most staggering events of the 19th century, the eruption of Krakatau in August of 1883. Not just the explosion itself, but the long and strange aftermath, the months of burning skies, the eyewitness accounts that contradict each other in deeply unsettling ways, and the psychological wound this event carved across an entire generation of people who could not understand what had happened to their world. If you are new here, subscribe right now. This is not a channel that skims the surface. We go into the places historians tend to skip over. We ask the questions that official accounts leave unanswered. And we stay until we find something real. Drop a comment below before we even begin. Did you know that the Krakatau eruption affected the skies of North America and Europe for nearly a full year? Most people do not. That gap in common knowledge is exactly the kind of thing that tells us history has been told too quickly, with too many important details left out. Stay with me to the end, because there is something in the final chapter of this story that almost no one discusses. Something about the survivors and about what they reported seeing in the days before the main eruption that the official Royal Society report of 1888 addressed only briefly before moving on. I want to go back to it, and once you hear it, I think you will want to go back to it too. Before the world broke. To understand how catastrophic Krakatau was, you first need to understand where it sat and what it was. The island of Krakatau, sometimes spelled Krakatoa in older English-language records, stood in the Sunda Strait, the narrow body of water separating the Indonesian islands of Java and Sumatra. This strait connects the Java Sea to the Indian Ocean, and in the 19th century it was one of the most heavily traveled shipping corridors in all of Southeast Asia. Dutch colonial vessels, British merchant ships, and steamers from a dozen nations passed through it regularly. Krakatau itself was not a new volcano. Dutch records from as far back as 1680 document the island as an active volcanic site. An eruption was noted in that year, and the island was reportedly uninhabited for much of the following 2 centuries, though fishing communities occasionally landed on its shores. By the mid-1800s, it had been quiet long enough that most regional authorities treated it as a geological curiosity rather than an active threat. A Dutch surveying party that mapped the island in the 1850s noted its unusual triple-peak structure. 3 volcanic cones occupying the island, named Perbuevotan in the north, Danan in the center, and Rakata in the south. What the surveys could not record was what was building beneath those peaks. In May of 1883, roughly 3 months before the main event, Krakatau gave its first serious modern warning. Seismic activity in the region had been elevated since late 1882, and on the 20th of May, 1883, Perbuevotan, the northernmost cone, began erupting. The eruptions were visible from the port city of Batavia, now known as Jakarta, roughly 160 kilometers to the northeast. Residents described columns of dark smoke and ash rising above the horizon, and ships passing through the strait reported ash falling on their decks. A small expedition organized shortly afterward included several colonial officials and civilian observers who landed on Krakatau in late May. Their accounts, preserved in reports from the Batavia Natural Science Society, describe a landscape already dramatically altered: sulfurous vents spitting steam, trees stripped of their leaves by ash, and the northern crater visibly active. One member of the expedition described the noise from Perbuevotan as resembling artillery fire, even at close range. And then, almost as suddenly as it had begun, the activity appeared to quiet. Through June and into July, reports from the strait suggested the eruptions had diminished. Ships passed through without major incident. Life in the coastal towns of Java and Sumatra continued normally. Officials in Batavia, monitoring the situation, apparently concluded that the episode was subsiding. That assumption was catastrophically wrong. What researchers examining the geological record since then have argued is that the apparent quieting in June and July was not a sign of pressure releasing. It may have been the opposite. The system may have been sealing itself, trapping magmatic gases, and building toward a threshold that, once crossed, would produce consequences no one in the strait or on either neighboring coast had any framework to anticipate. The weeks between late July and mid-August of 1883 saw a gradual return of activity. Ash emissions increased. The water in certain parts of the strait reportedly changed in temperature. Fishermen from coastal communities noted unusual disturbances on the surface of the water. An account preserved in Dutch colonial records from the regional archive in Batavia mentions sailors reporting a smell of sulfur strong enough to be nauseating even at a distance of several kilometers from the island. And yet, the populations of the coastal towns continued their daily routines. Because what choice did they have? The warnings were ambiguous. The authorities were not issuing evacuation orders. The volcano had quieted before, and life, as it always does, pushed forward under its own momentum. Until the morning of August 26, 1883, when Krakatau began in earnest what would become the most destructive volcanic sequence in modern recorded history. But before we arrive at the eruption itself, I want to pause on a detail that tends to get mentioned once and then passed over. Several witnesses in coastal communities on both sides of the strait reported in the days before the major eruption that the sea in the strait seemed to recede slightly. Not dramatically, not in any way that set off obvious alarm, but enough that some fishermen noticed their usual anchorage was shallower than expected, and that certain stretches of shoreline appeared to have retreated by a few meters. We cannot confirm exactly how widespread this observation was because the records are incomplete. Accounts differ on the timing and the scale. But the pattern is one that modern volcanologists and oceanographers associate with significant submarine geological activity, and it raises a question that no contemporary official report seems to have fully engaged with. How much did the local populations actually sense before the morning of August 26th? And why does that question sit quietly on the edges of the historical narrative, never quite becoming its center? Hold that question. We will come back to it. The day the ocean broke. The morning of August 26, 1883, began like a normal day in the Sunda Strait. Ships were moving through the channel. Fishing boats were out from the coastal villages. In the towns of Anjer and Teluk Betung on the Javanese coast, and in settlements along the Sumatran shore to the north, merchants were opening their stalls and residents were beginning their daily routines. At approximately 1 o'clock in the afternoon, local time, Krakatau erupted with a force that immediately dwarfed everything that had come before. A column of ash and steam rose to an altitude that observers estimated at more than 25 kilometers. The noise was described by witnesses on ships in the strait as something like continuous thunder, except louder, and with a deeper physical quality, a kind of pressure felt in the chest more than heard with the ears. The ash began falling across the strait almost immediately. Ships reported daylight turning to near-total darkness within hours. Captain W.J. Watson of the British merchant vessel Charles Ball was navigating the strait during the eruption, and his logbook entries, later reproduced in the Royal Society report of 1888, describe conditions that read like passages from a nightmare. The account speaks of chunks of pumice falling onto the deck, air becoming nearly unbreathable from sulfurous gases, the sea surface covered in floating volcanic rock, and a darkness so complete at midday that the crew could not see the length of their own ship. The eruptions continued through the afternoon and into the night of August 26th. The coastal towns experienced ashfall, and the noise from the volcano was heard well inland. But the full catastrophe had not yet arrived. It was still building. On the morning of August 27, 1883, at approximately 10 minutes past 10 in the morning, local time, the main event occurred. The precise moment is preserved in the log of a Dutch government telegraph station at Batavia, which recorded a disruption in its equipment corresponding to what we now understand to have been the moment of the largest single explosion. What happened at that moment is, in geological terms, described as a caldera collapse. The magma chamber beneath the island, partly emptied by the previous day and a half of eruptions, could no longer support the weight of the volcanic cones above it. Two of the three peaks, Perboevotan and Danan, did not simply explode outward. They collapsed inward and downward into the sea. The ocean, rushing in to fill the void, met the superheated rock and gas below the surface in a reaction that geologists classify as a phreatomagmatic explosion, the catastrophic conversion of seawater into steam at temperatures and pressures that produced an explosion of almost incomprehensible force. The sound produced by this event is documented as having been heard in Rodriguez Island, near Mauritius, at a distance of approximately 4,800 kilometers to the southwest. It was also heard in Diego Garcia in the Indian Ocean, in Colombo, in what is now Sri Lanka, and in Alice Springs in the Australian interior, more than 3,500 kilometers away. Reports compiled by the Royal Society noted that observers in these locations initially believed the sounds were artillery fire from a naval engagement. In some cases, local authorities dispatched ships or messengers to investigate before realizing the sounds were atmospheric in origin. The pressure wave produced by the explosion was not merely a sound, it was a measurable physical disturbance in the atmosphere, detectable with the barometers and barographs that meteorological stations around the world use to monitor air pressure. Barometric records from stations in London, Calcutta, Sydney, San Francisco, and elsewhere show pressure fluctuations in the days following August 27th. That researchers later calculated corresponded to the wave traveling around the planet at least 7 times before dissipating beyond measurable levels. Think about what that means. A single explosion on a small island in the Sunda Strait produced a physical disturbance in the atmosphere that wrapped around the entire Earth. Multiple times. The collapse of the island into the sea displaced an enormous volume of water. The resulting tsunami waves, some of which reached heights of 30 meters or more when they struck the coastlines of Java and Sumatra, were documented in post-event surveys by Dutch colonial engineers, published in official reports in 1884. Some estimates, depending on the source and the measurement methodology, suggest that certain stretches of the Javanese coast experienced wave run-up heights exceeding 35 meters. The overall picture, wherever the exact numbers settle, is consistent. The waves were devastating at a scale that the coastal communities had no context to comprehend. The town of Anjer was effectively erased. The lighthouse at Anjer, a structure of considerable mass, was destroyed. The town of Teluk Betung was struck by waves that carried the Dutch government steamship Barrow approximately 2.5 kilometers inland from the shore. The ship came to rest in the jungle. Its captain and crew were among the roughly 36,000 people who died in the disaster, the overwhelming majority of them killed not by the eruption itself, but by the waves that followed. 36,000 human beings. When you understand that these were dense coastal settlements and fishing communities whose residents had little to no warning and essentially nowhere to run, that number becomes something more than a statistic. It becomes a portrait of complete catastrophe. But here is something that almost never appears in the summary accounts. The tsunami did not arrive entirely without preceding signs. And the failure to read those signs is one of the most instructive and painful episodes in the entire history of this disaster. The wave nobody read. Before the major wave struck, the sea gave a signal. In the minutes before the arrival of the main wave, the water along stretches of the Javanese and Sumatran coastlines pulled back dramatically, exposing the seafloor, leaving fish stranded in shallow pools, and pulling boats off their moorings in the direction of the open water. This phenomenon, called a drawback, is one of the classic precursors to a tsunami. When the ocean behaves this way near a coast, it is because a large wave is approaching from offshore and drawing water toward itself as it moves. In the 19th century, this was not widely understood. There was no public education about tsunami behavior. There was no early warning system. And in most cases, there was no established cultural knowledge in these specific communities about what a retreating sea, in this context, meant. According to survivor accounts recorded by Dutch colonial officials in the weeks after the disaster, some residents of the affected areas actually walked out onto the exposed seafloor to collect the stranded fish. Others stood at the waterline and watched with curiosity as the sea retreated. A small number began moving inland on instinct. Most did not. The main wave struck within minutes of the drawback, and for the communities at the waterline, there was no meaningful interval between the warning and the wave. I want to be careful here. The accounts differ. Some testimonies recorded in the Dutch Colonial Archive suggest the drawback was brief and the wave arrived very quickly, leaving no practical window for evacuation, even for those who recognized the danger. Others suggest the interval was slightly longer. We cannot reconstruct the precise timeline from the records that survive, partly because many of the witnesses did not survive, and those who did were writing from memory days or weeks later under conditions of significant trauma. What the record does make clear is this. In the hours before the main waves arrived, some coastal residents did attempt to warn their neighbors. Survivor testimony from the village of Ketimbang on the Sumatran coast describes individuals calling out to those near the water as the sea retreated. Some Dutch officials and local administrators reportedly attempted to move people away from the waterfront after the morning explosions made clear that something catastrophic was happening on the island. Whether more organized action could have saved more lives is a question historians and emergency management researchers continue to examine. The honest answer is probably yes, but the infrastructure for such action simply did not exist in a form that could have been effective under these conditions. What I find particularly striking, and what tends to get compressed or omitted in shorter popular accounts of this event, is a specific detail in the survivor testimonies. The people who survived, disproportionately, were those who were already on high ground, or who moved uphill immediately upon hearing the large morning explosions, without waiting to see what would happen at the waterline. Several accounts describe individuals who ran uphill not because they understood what a tsunami was, but simply because the explosion was so enormous and so close that every instinct they had told them to get away from the sea. Instinct, in this case, was a more reliable guide than rational calculation, because rational calculation, in the absence of relevant knowledge, can lead to hesitation, and hesitation was lethal. What does this tell us about how disasters unfold and about what kinds of knowledge actually save lives? Drop a comment and tell me what you think, because this is not purely a historical question. It is a question about how communities carry knowledge forward across generations and how much gets lost in the spaces between. Now, the waves are gone, the island is in ruins, and somewhere high above the destruction, already drifting on upper-level winds that no instrument on the surface can yet detect, a fine invisible veil is beginning its slow migration toward the stratosphere. Something that will stay aloft for months. Something that will set the sky on fire from New York to London to Paris, and leave entire nations convinced that the world is ending. Let us talk about the bleeding sky. The sky that set the world on fire. The Royal Society of London began systematically compiling testimony in the months following the Krakatau eruption. Their resulting publication, released in 1888 under the title The Eruption of Krakatoa and Subsequent Phenomena, edited by G.J. Simons, is one of the most remarkable scientific documents of the 19th century. It runs to more than 500 pages and draws on reports from meteorological stations, ship logs, missionary correspondence, colonial records, and private letters from observers across 6 continents. If you want to understand the true global scale of what Krakatau unleashed, this report is the starting point. What the Royal Society found when they began gathering atmospheric observations from around the world was that the eruption had injected an enormous quantity of material into the stratosphere. Not just ash, which is relatively heavy and tends to fall out of the atmosphere within days or weeks. What Krakatau sent aloft was something finer and more persistent, microscopic particles of volcanic glass, and more importantly, sulfur dioxide gas, which reacted with water vapor in the upper atmosphere to form tiny droplets of sulfuric acid. These droplets were small enough and light enough to remain suspended in the stratosphere for months. Suspended they remained, drifting on upper-level winds, spreading slowly across the globe, invisible from the ground, but with a profound effect on the way sunlight traveled through the atmosphere. These suspended particles scattered light, and not all wavelengths equally. The scattering preferentially affected the shorter wavelengths of visible light, and this meant that when the sun was near the horizon, at dawn or dusk, the effect became visible to the naked eye. The sky glowed, not orange-yellow the way a normal sunset does, but deep red and green, and sometimes a pale unearthly blue. Observers in Europe began noting unusual atmospheric effects in September of 1883. In October, the effects became more dramatic. By November and December, they had reached a level that caused genuine public alarm across multiple countries. In New Haven, Connecticut, in late November of 1883, residents called the local fire department after seeing what appeared to be a fire glow on the horizon. The same thing happened, according to newspaper accounts preserved in archive collections of New England historical societies in cities across the northeastern United States. The New York Times covered the phenomenon with a combination of scientific speculation and barely disguised bewilderment. Correspondents wrote in from dozens of locations describing the sky in terms that suggest genuine awe and, in many cases, genuine fear. In London, the November and December sunsets of 1883 were described in terms that sound more like poetry than meteorology. The Pall Mall Gazette ran letters from readers who described the colors as unlike anything they had witnessed in their lifetimes. The painter William Ashcroft was moved to produce more than 500 sketches of the London sky during this period, many of which are now held in the archive of the Meteorological Office in Exeter. Ashcroft's sketches, later submitted to the Royal Society as observational data, document colors that look, to a modern eye, like something between a Turner seascape and a science fiction illustration. In continental Europe, French astronomers and meteorologists writing in the Comptes Rendus of the French Academy of Sciences in late 1883 noted the atmospheric anomaly and attempted to connect it to the Krakatau eruption, which had been reported in the European press. But the connection was not yet widely accepted, the mechanism was not understood, and the visual evidence was so dramatic, so far outside normal atmospheric experience, that many ordinary observers refused to accept a volcanic explanation. Something that had happened on a small island in the Dutch East Indies, months ago and thousands of miles away, could not possibly have anything to do with the sky above Paris in December. That resistance, that gap between cause and effect across both distance and time, is one of the more psychologically interesting aspects of this whole episode. Because it was not simply confusion, it was the collision of two different ways of making sense of the world. The scientific attempt to trace a global mechanism across space and months, and the immediate embodied experience of watching your own sky burn in colors you have no name for. And this leads directly to something that the scientific literature has examined in some depth, but that popular accounts of the eruption almost entirely overlook. There was also the matter of the bishop's ring. Named after Reverend Sereno Bishop of Honolulu, who first formally described the phenomenon in 1883, the bishop's ring was a brownish or pinkish halo visible around the sun during this period, sometimes extending to an angular radius of around 20 or 25 degrees. Observers around the world noted it. Astronomers logged it in their records. The Royal Society report of 1888 includes a detailed section on Bishop's Ring observations gathered from correspondence in multiple countries. And yet, outside of specialized meteorological literature, the phenomenon barely appears in popular memory of the Krakatau story. Why does the sky change its colors for months, and why does that not become the central part of the story we tell about this event? What does it say about the way we compress history when that long atmospheric aftermath, the part that most directly affected the most people across the largest geography, gets reduced to a footnote? Hold that question, because the next chapter takes it further. The sky was changing, the public was frightened, the scientists were scrambling. And the gap between what people were seeing and what they were being told was opening a psychological wound that is far more interesting and far more relevant to us today than most accounts of this disaster let on. The global mind under pressure. The late 19th century was a period of considerable confidence in Western scientific and institutional knowledge. The Industrial Revolution had delivered railways, telegraphs, and steamships. Germ theory had begun transforming medicine. Geological and astronomical science had expanded the understood timeline of the Earth and universe far beyond what Scripture had permitted. There was a widespread sense, particularly among the educated classes of Europe and North America, that the natural world was becoming increasingly legible, that its mysteries were being catalogued, named, and explained. Krakatau disrupted that confidence in a way that went beyond the death toll and the physical destruction. It disrupted it in the sky. Every day for months, ordinary people in cities that considered themselves the centers of civilization looked up and saw something they could not explain, something their governments, scientists, and newspapers struggled to explain coherently. And the explanations that did emerge arrived slowly, piecemeal, and in language that was not easily accessible to most readers. The gap between the event and the public understanding of the event was enormous. Into that gap poured a remarkable diversity of interpretation. Religious communities across multiple continents treated the vivid skies as signs of divine judgment. Sermons preached in churches in England, France, and the United States in the autumn of 1883 drew on the imagery of the Book of Revelation to interpret the red skies. The blood moon language of Scripture seemed to many observers to describe precisely what they were seeing. Several newspaper archives from this period contain accounts of congregations that, after a particularly vivid sunset, gathered spontaneously to pray. Not at scheduled services, spontaneously, pulled together by the sky. At the same time, the scientific community was producing a competing narrative. A paper published in the journal Nature in late 1883 by the astronomer and science writer Norman Lockyer was among the earliest scientific attempts to explain the connection between the eruption and the atmospheric effects. Lockyer and others argued that fine particles in the upper atmosphere were acting as a natural optical filter, a known if poorly documented consequence of major volcanic events. But their reach was limited. This was not information that filtered quickly into the lived experience of ordinary people watching their evenings turn the color of a wound. The bishop's ring faded. The vivid sunsets gradually dimmed through the first half of 1884. And then, almost imperceptibly, the sky returned to something approaching normal. But what had happened in the interval, in that sustained period of visual strangeness, had not simply been forgotten. It had been absorbed into sermons, into personal letters, into the cultural imagination of a generation that had watched the sky behave in ways their entire framework of normality could not accommodate. Some historians of science and culture have noted that the 1880s were a period of unusual intensity in apocalyptic and eschatological thinking across Western societies. Popular fiction increasingly engaged with themes of catastrophe, extinction, and civilizational collapse. H.G. Wells, who was in his teenage years during the Krakatau aftermath, would go on to write about volcanic catastrophe and civilizational destruction with a specificity and urgency that seems, in retrospect, to draw on a cultural atmosphere that the Krakatau event helped create. His novel, The War of the Worlds, published in 1898, opens with an almost clinical description of humanity's failure to perceive an approaching catastrophe until it is too late. The echo is imperfect. The cultural context was complex, but the resonance is worth noticing. We cannot prove a direct causal link between the eruption and any particular literary or cultural movement. The evidence does not work that cleanly. But the suggestion that an event which literally changed the appearance of the sky over much of the industrialized world for months without immediate or satisfying explanation would have had no effect on the cultural imagination of the period strain's credibility. What do you think? I genuinely want to know. Leave a comment below. Does the idea that the sky's behavior, sustained and unexplained, can shape a generation's sense of what is possible and what is safe, resonate with how you think about history? Because what we are discussing here is not just volcanology. It is how collective incomprehension, experienced on a global scale, reshapes the stories a civilization tells itself about its own security and its own future. Now I want to turn to something that has stayed with me since the first time I read the primary sources carefully. Something about the historical record that the standard account tends to smooth over. And I think it should stay with you too. This is a good moment to subscribe to EPOCH RESET if you have not already. Every week we go back into the archives, into the records that did not make it into the summary, and ask the questions that should have been asked long ago. Hit subscribe and stay with me for this final chapter, because the part of this story that most people have never heard is waiting, and it is the part that I think changes how the whole thing looks. What the archive leaves out, every major historical event develops something that functions like an official version. Not government-mandated propaganda necessarily, but a standard narrative, the version that appears in encyclopedias, in educational texts, in documentary summaries. For Krakatau, 1883, the standard account is clear enough. A volcanic island erupted catastrophically. Tens of thousands of people were killed. The eruption briefly altered global climate and produced atmospheric phenomena that disturbed observers worldwide. The scientific explanation was eventually developed, and we now understand what happened at a level of detail unavailable to those who lived through it. That narrative is substantially correct. And yet, when you go into the primary sources, into the colonial records held in archives in the Netherlands and Indonesia, into the ship logs and missionary correspondence and survivor testimonies compiled in the aftermath, you find details that do not fit smoothly into the standard account, not contradictions that invalidate the overall picture. But edges and gaps that suggest the full story is considerably more complex than the version that circulates most widely. Here is one that I find particularly striking. In survivor testimonies collected by Dutch colonial officials in the weeks following the disaster, a recurring element appears that receives relatively little attention in summary accounts. Multiple survivors from communities on both sides of the strait describe in the hours and days before the major eruption on August 27th unusual animal behavior: dogs refusing to go near the water, birds abandoning coastal trees and moving inland, cattle that could not be led toward the shore, fish described as behaving erratically at the surface. Unusual animal behavior before geological events is a documented phenomenon that appears in the scientific literature in relation to multiple major earthquakes and volcanic events, with modern research proposing various mechanisms including sensitivity to infrasound and to ground vibrations below the threshold of human perception. This is not a fringe observation, but in the Royal Society report of 1888, the primary scientific synthesis of the Krakatau event, this dimension of the testimony receives, at best, a passing mention. The focus of the report, understandably, was on the measurable physical phenomena: the atmospheric pressure waves, the optical effects, the tsunami heights, the geological changes to the island. The animal behavior accounts were the kind of testimony that the scientific standards of the period were not well equipped to evaluate, so they tended to end up in the margins. The question is whether those margins matter. If the animal behavior observations are accurate, and we cannot fully confirm this given the fragmentary nature of the surviving testimony, then they suggest the geological event was producing precursory signals in the environment for days before the main eruption, signals that the non-human inhabitants of the region were detecting and responding to, while the human populations were not, or not in an organized way that led to protective action. There is a second element in the historical record that I want to flag, and I want to be clear that the accounts differ here and interpretation is genuinely contested. Several Dutch colonial records from the period immediately following the disaster contain references to complaints by local village leaders in the weeks and months before the eruption about unusual water conditions in the strait. Discoloration, unusual surface warmth, disturbances that did not match the normal seasonal patterns. These complaints were apparently forwarded to regional colonial authorities and, in at least some cases, generated a response that amounted to acknowledgement followed by inaction. Whether those warnings, even if taken seriously and acted upon, could have prompted any kind of useful protective response is deeply uncertain. The logistical and political challenges of ordering the evacuation of large coastal populations in the Dutch East Indies in 1883, based on reports of unusual water conditions near a historically active volcanic island, would have been formidable. The evidence does not suggest that any authority deliberately ignored clear warnings of an imminent catastrophe. But the existence of those reports in the record and the gap between what they indicated and what action was taken is worth sitting with carefully, because it tells us something about how information travels, or fails to travel, from the people closest to a developing threat to the people with the authority and resources to respond to it. That gap is not unique to 1883. It is one of the structural features of how institutions process risk. And understanding it historically is part of how we learn to do better. And then there is the long tail of this story, the part that rarely makes it into the condensed account, the part that I think matters most of all. The physical landscape of the Sunda Strait was permanently altered. New submerged ridges and valleys where none had been before. Depths that had been tens of meters now measuring hundreds. The coastal communities that had been destroyed were not rebuilt in their original locations. Some were reconstructed slightly inland. Some were not rebuilt at all. The town of Anjer was reconstructed, but in a form bearing little resemblance to what had been there before. In the regional colonial records held in the Dutch National Archives in The Hague, files from 1883 through approximately 1887 deal almost entirely with administrative aftermath, land ownership disputes, inheritance claims for estates of those who died without heirs, petitions for tax relief from communities that had lost their productive capacity, reports on the condition of survivors who had been relocated to inland areas. These records paint a picture of the long tale of catastrophe that the dramatic narrative of the explosion itself tends to obscure. The death toll of 36,000 is a number that can be spoken in seconds. The administrative and human reality it represents was still being processed in official files and personal letters years later. The psychological dimension of the long aftermath is harder to document because the 19th century lacked the vocabulary and institutional framework to recognize and record what we would today call trauma or post-traumatic stress. But it shows up in the historical record indirectly, in unusual patterns of migration away from coastal areas in the years following the disaster, in the reduced fishing activity along stretches of coastline that had previously supported substantial communities, in accounts from missionaries and colonial administrators describing communities where elderly residents had stopped talking about the sea, where children were kept away from the waterfront, where the cultural relationship to the ocean, foundational to the identity and livelihood of any fishing community, had been severed or profoundly altered. One particularly striking account, recorded in a missionary report from the Sumatran coast and preserved in the archive of the Netherlands Missionary Society, describes a village that developed a specific practice in the months following the disaster, posting a night watchman at the waterline, not during the day, only at night. The watchman was instructed to wake the entire village if the sea began to behave unusually. This practice was maintained, according to the report, for at least 3 years following the eruption. Think about what that tells you, not just about fear, but about how communities adapt in the absence of institutional support, in the absence of early warning systems, in the absence of scientific explanation, in the absence of governmental reassurance. A village of fishing families on the Sumatran coast invented their own early warning protocol. Based on lived experience, on traumatic memory, on the basic human impulse to make sure that what happened once does not happen again without warning. The global climate effects of the eruption were also long-lasting. In the year following the eruption, 1884, global average surface temperatures fell by an estimated 1.2 degrees Celsius. In a world already living close to agricultural margins in many regions, this cooling had real consequences. Crop failures were reported in parts of the United States and Europe. The summer of 1884 was notably cold in northern Europe and parts of North America, and contemporary accounts in agricultural and meteorological records document the anomaly with some bewilderment. The connection to Krakatau was made by scientists relatively quickly, in comparative terms, but the public understanding lagged, as it almost always does. The suffering was local and immediate, the cause was global and historical. And that gap between local experience and global causation is one that remains in many ways as difficult to navigate today as it was in 1884. And then, in the longer term, something extraordinary happened. Life returned to Krakatau. For years after the eruption, the remnant island of Krakatoa was described by scientific visitors as utterly desolate, a landscape of bare volcanic rock with no visible vegetation and no animal life. The first systematic scientific survey, conducted by a Dutch scientific expedition in May of 1884, found it lifeless. A second survey in 1886 found the first signs of returning plant life, traces of vegetation in crevices where wind-blown seeds had found some purchase. By 1897, when another survey was conducted and published in the scientific literature, the island had developed a thin but discernible covering of ferns, mosses, and grasses. Small insects had returned. What had been a dead volcanic rock was slowly developing into a young, biodiverse ecosystem. Biologists who documented this process recognized that Krakatau offered something genuinely unusual in science, a near-complete controlled experiment in ecological succession, a chance to observe how life recolonizes a landscape starting from essentially zero. 44 years after the Great Eruption, in 1927, a new volcanic island broke the surface of the sea in the area where Krakatau had stood. It was named Anak Krakatau, which translates roughly as Child of Krakatoa. It has been active intermittently ever since. In December of 2018, it collapsed partially into the sea, triggering a tsunami that killed more than 400 people on the coasts of Java and Sumatra. The strait is still alive. The geology has not finished with this place. The burning skies have faded. The tsunamis have retreated. The administrative records of the disaster have been transferred to archives, catalogued, and in some cases, digitized. The 36,000 dead have, for the most part, no individual memorials, no headstones, no public monuments in the specific places where they lived and died. But the strait is still there. Anak Krakatau is still there. And somewhere in the layers of the seafloor between Java and Sumatra, mixed in with the sediment and the volcanic rock, are the traces of everything that happened on August 27, 1883. The story does not end. It only pauses. And that is worth sitting with for a long time. If you stayed with this to the end, I want to hear from you. Which part of this story surprised you most? The burning skies over Poughkeepsie and Paris? The Sumatran village that posted a night watchman at the waterline for 3 years? The way a single geological event draped a veil over the entire planet and went largely unexplained to the public for years? Tell me in the comments. Because history gets richer with more voices around it, and this is exactly the kind of story that deserves that. And subscribe to EPOCH RESET if you are not already. Every week we go back into the archives, into the records that did not make it into the summary, into the files that got quietly set aside. Every case file, every detail that should have made it into the textbook but did not. That is where we live. I am Elliot Carter. This has been EPOCH RESET, and I will see you in the next one.